Hello everyone. Let us consider the permutation and combination problems in this video. So for the TS EAMCET September 10, 2020 Shift 1 exam, only two permutation and combination problems were asked, and I believe they reduced the number of questions from PNC because of COVID. Some of the syllabus was reduced, hence the number of questions that they asked were reduced. So let us look at the two problems one by one. So question first is the total number of 3-digit and 5-digit numbers which can be formed by using the digits 0, 1, 2, 3, 4, 5, but using each digit not more than once in each number. So I have to make 3-digit and 5-digit numbers, but I cannot use any digit more than once. So first let us look at the 3-digit numbers. For the 3-digit numbers, let us consider this. This is the 1th place, this is 10th place, and this is 100th place. So I have 0, 1, 2, 3, 4, 5 with me. So total is 6. I have 6 options for which I can make 3-digit numbers. So for this one, maybe I have 6 options. For this, I have, since 1 is used here and it cannot be repeated, so only 5 options will remain, and 1 again was used here, so only 4 options will remain. So I can make 3-digit numbers in 6 into 5 into 4 ways, which is 3120. But in this case, I have considered 0 as well over here, right? So if I make a number like this 0, 4, 5 or 0, 2, 3, these are not 3-digit numbers. These are 2-digit numbers because this is 45 and this is 23. So this approach is wrong, right? Yeah, I mean, this approach is wrong. We will have to reconsider how to compute the number of 3-digit numbers. So let us consider it again. 1, 2, 3. This is 100th, 10th, and 1th place. I cannot use 0 here. I cannot use 0 here. So out of 0, 1, 2, 3, 4, 5, I cannot use 0. I have 5 options I can use. Out of 1, 2, 3, 4, and 5, I can use anyone. So I have 5 choices. Now I used 1 over here, so I will have 4 choices over here, but now 0 is also available. So 4 plus 1 is 5. Again, I am using 1 digit over here, so now I will be left with 4. So total number of 3-digit numbers for the given condition would be what? 25 times 4 is 100. Now let us consider 5-digit numbers. 1, 2, 3, 4, 5. 5-digit numbers, but I cannot use 0 here. I cannot use 0, so I will have 5 choices for this one. I used 1 digit over here, so 4 digits will be available, but 0 is also available. So 4 plus 1, 5 are available now. For this, again 4 will be available. For here 3 will be available. For here 2 will be available, right? So 5 times 5 is 25, times 4 is 100, times 3 is 300, times 2 is 600. So that is 5 times 5 times 4 times 3 times 2 is equals to 600. So total will be what? 100 plus 600, which is equal to 700. So option C is correct. So that was a very easy and straightforward question, should not take more than 1 minute. Okay. Now let us look at second problem. At an election, a voter may vote for any number of candidates not exceeding the number to be elected. If 4 candidates are to be selected out of the 12 contestants in the election and a voter votes for at least one candidate, then the number of ways in which a voter can vote is blank. So the first statement is voter can vote for any number of candidates not exceeding the number to be elected. So if 4 candidates will be selected, 4 candidates to be selected. So if I am a voter, I can vote for any number of candidates, not more than 4. So I can vote for 1 candidate, or I may vote for 2 candidates, I may vote for 3, I may vote for 4, or I may not vote for anyone, that is 0, but it is given that a voter votes for at least 1 candidate, so 0 is not an option. So 1, 2, 3 or 4. In how many ways I can vote for 1 candidate? Out of 12 I choose 1. So 12 ways. in how many ways can I vote for two candidates? First, I have 12 candidates from which I can choose. Now, since I have chosen one candidate, I'm left with 11. Okay. Similarly, for 3, 12 into 11 into 10, and for 4, 12 into 11 into 10 into 9. But here's the trick in this one. I have chosen 2, but their order does not matter, so I will be dividing it by 2 factorial, or this can easily be said as 12C2. The number of ways in which I can choose one candidate from 12 is 12C1. The number of ways in which I can choose 2 from 12 is 12C2. So let us not use this method. 12C3, 12C4, right? The number of ways in which you can choose one person out of 12 is 12C1. The number of ways in which I can choose two candidates from 12 is 12C2. Similarly, for 3 is 12C3, for 4 is 12C4. Now we just have to calculate the value of 12C1. 12C1 is what? 12. 12C2 is what? 12 into 11 into 10 factorial by 2 into 10 factorial. This will get cancelled. 12 into 11 into 10 into 9 factorial by 3 factorial is 3 into 2 into 9 factorial. This will be cancelled. Plus 12 into 11 into 10 into 9 into 8 factorial. 4 factorial is what? 4 times 3 times 2 times 1 times 8 factorial. So this will be cancelled. Now I'll cancel this here. 6. 3 times 2 is 6. 6 times 12 is 6 times 2 is 12. 4 times 3 is 12. This will be cancelled. This will be 5. So my calculations are 12 plus 6 into 11 plus 2 into 11 into 10 plus 11 into 5 into 9. This is 10, sorry. So 12 plus 66 plus 220 plus 55 times 9 is 495, right? So this is what? 88 plus 220 plus 495, 695 plus 20 is 700 and what is it? 695, 715. 495, 220, 695, 605, 705, 705, 793. Okay, we're done. 793. So option A is correct. So these were the two problems that were asked. Usually they would ask 3 or 4 questions in which one would be circular permutations, but this time they haven't. Because of COVID, they have reduced the syllabus. And so that's it for this video. We'll see you next time. Thank you.